So next speaker is Christophe Yèche from CEA-Saclay, and he will talk about DESI-II, a window to the primordial universe.
Okay, so I'm going to present DESI-II. It's a sequel of DESI. And let me start with the timelines, both for DESI and DESI-II. In principle, we will finish DESI in 2029, 2028, and we will start DESI-II in 2029, and it will be a 6-year program, and we expect minimal upgrades of the instruments with an incremental installation. And we have 3 scientific programs: a dark matter study with bright time, high density survey with both bright and gray time, and finally, what is interesting for CFHT community is IZ survey, and this will be for dark time. Let me summarize the science with a sketch. You have in x-axis the redshift, and in y-axis, and you have along the x-axis a spatial scale. So what we have studied with DESI is the expansion of the history of the expansion of the universe. And so this means that we studied with acoustic oscillation, and we have a probe of dark energy and time evolution of dark energy. And we can also study the modification of the gravity. It's what we have seen with talk. And what we will do with DESI-II, we will, at low redshift, we will continue to study the modified gravity and also the dark matter. And for that, we have 2 surveys. We have the dark matter program. Here we want to measure the redshift or the velocity of the star. And here you have the first program is really the study of stellar stream in Milky Way. And we have also studies of mass density profile for dwarf galaxies. And with this information, you can compute or you can measure the dark matter power spectrum. And you can see this here. And as a function of the scale or as a function of the mass halo, and we are in this window, window is terrible. I mean, so you can see this with this green window, we are probing the power spectrum in this region. And so this means that we can test alternative dark matter models such as fuzzy, warm, or interacting dark matter. We have also a high density survey program. Here, this means that we are going to multiply by factor 3 to 5 the density compared to what we are using for DESI with BGS and LRGs. And you can see here the difference in terms of density. And the size of this high density survey would be of the order of 5 to 10,000 square degree, with a density which will be at the order of 5 to 10,000 targets per square degree. Here you can see the list of the topics that we can study with this high density program. I'm not going to go to all these topics, but I can keep the last one. And here the idea is to use a density split as a function of the density. So you can see the different sample, and you can see here the gain that we have on the growth rate, I mean F sigma 8, and there is a gain which can be of the order of a factor 3 or even 5 in some cases. Let me go to the second part. The second part is to study at higher redshift above 2, from 2 to 3. And here, what we want to study, for instance, is really primordial feature. We want to study the inflation with non-Gaussianity. And we want also to study the light relics or the neutrino masses. And you have here some example of generic ID survey. We want to study in the range between 2.2 and 3.5 with a surface and area of the order of 5,000 square degrees. We will use as a tracer of the matter Lyman-Wade galaxies and the Lyman alpha emitters. This means that to get the redshift for us, we need an exposure time of the order of 1 to 2 hours. And the target density will be of the order of 1,000 target per square degree. And with this program, we will use half of the dark time. And we will study dark energy. And you can see here the new measurements that we can expect with the green dots. And you can see that, for instance, you can test new models from lambda CDM. You can compare the dotted red curve to the flat line, which is the lambda CDM. We want also to study the inflations through the primordial non-Gaussian case. We will expect our sensitivity by a factor 2. And finally, we can measure the neutrino masses of the order of 20 millielectron volt. So we have two tracers. The first tracer is LBG, and for the selection of this tracer, we are using diode ROPA techniques. You can see this here. You have U minus G, G minus R. What we want to measure is this decrement in the blue part of the spectra. So this means with U minus G, you have just to select objects above a flat line. And but you have also to reject these red dots, which correspond to stars. So at the end, you have this selection polygon. And the point for this kind of selection is that we need a very deep U-band. And with LSST will be available not before 2028. Certainly at the depths that we want, it will be in 2030, something like that. And we did some pilot surveys with a UVO part, and you can see the results, the efficiency that we have. We have an efficiency of the order of 70%. And what's very important in our selection that is we don't have only absorption line here for the Lyman alpha. It's not pure LBGs without the Lyman alpha line. Actually, 80% of our selection presents an emission light. And what is more interesting for us now is really to go to a selection with medium bands. And you have here these 5 or 6 medium bands. And it's what we are proposing for this community. Here, the selection is almost orthogonal. What we want to observe is an excess of flux above reference. So this is the selection that we are planning. And we will have a different galaxy population. This means with low stellar mass and younger edges. And of course, with this kind of selection, we expect a higher efficiency with a lower exposure time. And we also did a pilot survey with DESI, and you can see for the 5 medium bands, the efficiency that we achieve, which is of the order of 80%, so higher than the efficiency that we get with the dropout selection. And of course, CFHT will be very efficient for the bluest bands and can complement the IBIS program that the thing is going to present on the next talk. And we have already submitted to the LOI project, and the name of this project is POLO, which means blue in Hawaiian. And just to summarize, for the DESI-II program, we have this ID program, with a study of the dark energy in the new region in redshift, with a study of primordial universe. And for that, you need a selection of LBGs and LAEs. And we have also these DESI-II programs which are around the topic of dark matter and high density program. And the point that I want to stress is that even if CFHT imaging is more relevant to the IC program, as soon as you are a DESI member, you can take part in any of these programs. I mean, the dark matter program, the high density program, and the IC program. Thank you.
Thank you. Questions?
So I'm not sure I understand you. You mentioned the U-band selection, but you talk about LSST, but DESI is at kid peak, right?
Yeah.
So how do you...
Okay, so for all the selection, we will use an equatorial stripe. Well, the plan is to have 5,000 square degrees. So this means between minus 15 and plus 15 index. That's the idea. So it's feasible from LSST and from CFHT and from DESI, of course.
More questions? I do have one. So you mentioned the 5 medium band filters in the G band, right?
Yeah.
So this means that in terms of efficiencies compared to you drop out selection where you just use the broad filters, is it much longer integration time? So you need to do the 5 bands with quite some depth.
No,
Is it longer at the end?
There is at the end almost a factor 5. I mean, sure. But the magic number is the depth that you need, either for the broadband or for the medium band, is 25 in magnitude, or 125, between 25 and 25.5. So this means that if you are in the blue, as you are less efficient, it's a bit slower, but at the end, as you have five bands, it's a factor maybe 3 compared to a broadband survey in U-band.
And the fact that you will select preferentially emission line galaxies, I guess at the end this introduced kind of not really strange completeness in terms of mass and so on. So how does it?
Yeah, science. I think that our final goal will be certainly to have both the U-band, the U-dropper selection using LSST, for instance, and this medium band selection. You have 2 different populations. For the clustering, you have different bias. Certainly with the LBG selection, the bias is a bit higher. But on the other hand, it's more difficult to measure the redshift. You are less efficient. So it's, at the end, it's a kind of trade-off. So it's very, I think, in terms of science, in terms of systematics, it's very important to have in parallel these 2 selections, I think.
So if I remember correctly, the community survey will start in 2028 and DESI-II will start in 2029. Do you think if it's enough time to get the data on time for the DESI-II targeting? I don't know if that's a question for you.
No, I feel that the thing is going to present with IBIS. So IBIS will start earlier. So in certain sense, you can start, for instance, with these bands, and after you can go to the other bands. So you can try to share the observation between the different bands. And so for sure, that's important to have the U-band, the bluest bands of the 5 bands, I would say in early 2029, because you need to process them. And so for sure, you have to start to observe this region in 2028. Yeah. But it can be incremental. You don't need to have the 5,000 square degree at the beginning of your survey. You can have in parallel the preparation with the imaging and the observation with the spectroscopic survey.
Okay, so let's move. So, thank you.